Hi, it is JIT UA Courses, and welcome to the 8th lesson of the .NET Developer series in which we will cover the most relevant topics to become a .NET developer. So hit the subscribe button and bell to see new videos on our channel. Okay, let's go. In this lesson, we will learn about class inheritance and typecasting in C#. Also, we will go through such things as boxing and unboxing, null type, and generic types. If this sounds interesting to you, don't hesitate and hit the like button. So we will start from class inheritance. Let's remember once again that a program is not just a line-by-line set of instructions, but the interaction of class objects, the exchange of their characteristics, and the operation of their methods. We also know that there are only two data types in C#, value and reference types. But the truth is that to simplify the internal workings of a programming language, all objects of classes or structures without exception must have some common functionality and certain characteristics. And so that the developers of the language, as well as us as users, do not have to write the same set of identical methods and characteristics over and over again, the concept of type inheritance is used. Yes, if we create some base, parent, type with a certain set of characteristics and methods, and then create a new type, but declare it to be a descendant of the base, parent. It will also have the characteristics and methods of the parent class, although we did not write a single new line of code in it. Like a bike, it can have different manufacturers, colors, and specializations, but essentially all bikes are descendants of the original bike concept, like two wheels, pedals, and handlebars. It can turn and move forward if you are rotating the pedals. So even new manufacturers should not reinvent all these things, they can focus on improving some particular things, but the base is the same, so it's much easier. The main purpose of inheritance is to reuse common functionality in different classes that must have the same characteristics and behavior. This significantly speeds up the writing of the program code and facilitates the use of classes that are in the same hierarchy. All classes in .NET, even the ones we create, as well as base types like system.int32, are implicitly derived from the object class. Even if we don't specify the object class as the base class, by default the object class is implicitly still at the top of the inheritance hierarchy. Therefore, all types and classes can implement those methods that are defined in the system.object class. ToString. The toString method is used to obtain a textual representation of this object. For basic types, their string value will simply be output. For classes, this method outputs the fully qualified class name, specifying the namespace in which the class is defined. It is worth noting that different technologies on the .NET platform actively use the toString method for different purposes. In particular, the same console.writeLine method outputs the string representation of the object by default. Therefore, if we need to output the string representation of the object to the console, then when passing the object to the console.writeLine method, it is not necessary to use the toString method, it is called implicitly the getHashCode method. The getHashCode method allows you to return some numerical value that will correspond to this object or its hashcode, unique key. By this number, for example, you can compare objects. getType method. The getType method allows you to get the type of this object. Equals method. The equals method allows you to compare two objects for equality. As a parameter, it accepts an object for comparison in the form of a type object and returns true if both objects are equal. And if two complex objects should be compared, as in this case, it is better to use the equals method, rather than the standard equals operation. As you can see from the diagram, the object type is the base type for everything in C#. For reference types, they imitate it directly, as well as for value types, they imitate it through the valueType type. But the concept remains constant, all types in C# are objects. Typecasting. Next, we go to the concept of typecasting from one to another. For example, we have such a class hierarchy. Object. Then account. Then user account. Where object we follow by default, the account type is the type that represents the account in our system. And the user account type represents the account of an ordinary user. Ascending casting. Ascending cast is when we bring a type from the bottom, in the hierarchy, to the top. For example, when we need to refer to user account as an account or as an object. We can express this either as writing an object to a variable with a higher type. Why is this necessary? So that in the program we can manipulate general objects and perform operations with them without going into details. For example, we can use different accounts in our system, for admin, for regular user, for premium user, etc. The details of these accounts will be different, but there is no need to add new functionality to our program every time to explain how to process a premium account. Like an admin account, we can have functionality just how to work with an account, and thanks to casting, the details will be leveled, and the program will simply work with basic accounts objects and accounts. Conversion of types through the type of a variable is called implicit casting, because the compiler automatically understands to which type the conversion should be made based on the type of the variable. Downward casting. Downward casting is when we try to move from a higher type in the hierarchy, base, to a lower, derived, type. For example, when we have an account, and there is a need to refer to it as an user account. For this, we use the name of the type to which we want to cast in parentheses, as this code example. Why do you need a downward casting? It is needed in situations when we don't just need basic details about an object, but we need the specific details that it has. For example, we want to replenish the balance of the premium account, but we can't do this with the basic account, because it simply does not have this property, so we need to perform a downward cast from the basic account to the premium account. But the problem is that if the object that was written to the account variable is not a premium account object, our program will have an error and break. So we need ways to safely cast types without error. Type casting with the help of the class name in parentheses is called explicit casting, because here we clearly indicate the type, or explicit casting. Okay, now we are a little more familiar with the concept of type casting. But in C#, we also have a handy syntax feature for this. First, we can use the as keyword. With its help, the program tries to convert the expression to a certain type but does not throw an exception. If the conversion fails, the expression will contain a null value, more on that later. Say this code example. It is worth noting that the employee variable here is defined not simply as an employee variable, but as employee with a question mark. A question mark is placed after the name of the type, which indicates that the variable can store null values as well as employee values. The second way is to check if the cast is a valid transformation using the is keyword. If the value to the left of the operator is of the type specified to the right of the operator, then the is operator returns true, otherwise, it returns false. Moreover, the is operator allows you to automatically convert the value of the type, if this value represents the given type. Like this code example, the expression if person is employee checks whether the variable person is an object of type employee. And if person is an employee object, then automatically converts the value of the variable person to the type employee, and the converted value stores the variable employee. Next, in the if block, we can use the employee object as a value of type employee. The next topic is boxing, unboxing and generics. In addition to common types, the .NET framework also supports generics and even the creation of generic methods. To understand why they exist, let's first look at a problem that could arise before the appearance of generic types. Let's look at an example. Let's say we define a class to store user data. Here the user ID is set as a numeric value, like it is the value 1, 2, 3, 4, and so on. However, string values are often used for the identifier. And at the time of writing the class, we may not know for sure what is better to choose for storing the identifier, strings or numbers, and it would seem that in order to get out of such a situation, we can define the ID property as an object type property. Since the object type is a universal type from which all types are inherited, accordingly, we can store both strings and numbers in the properties of this type. This class could then be used to create users in the application. Everything seems to work perfectly, but this solution is not very optimal. The fact is that in this case we are faced with such phenomena as boxing and unboxing. So, when passing an int value to the constructor, this value is packed into the object type. To get data into a variable of type int, you need to unpack. Boxing involves converting a value type object to an object type. During packaging, the CLR wraps the values into a system.objectType object and stores them in a managed heap. Unboxing, on the other hand, involves converting an object type to a value type and transferring its memory to the stack. Packing and unpacking lead to performance degradation because the system has to perform the necessary memory conversions. In addition, there is another problem, the problem of type safety. Yes, we will get an error when running the program like in this code example. To address these issues, support for generic types, also often called universal types, was added to C#. Generic types allow you to specify the type to be used. Therefore, let's define the person class in this example. The angle brackets in the description of class person T indicate that the class is generic, and the type T enclosed in the angle brackets will be used by that class. It is not necessary to use the letter T, it can be any other letter or set of characters. Moreover, at the stage of writing the code, we do not know what type it will be, it can be any type. Therefore, the parameter T in the angle brackets is also called a universal parameter, since any type can be substituted for it. For example, instead of the T parameter, you can use an int object, that is, a number that represents the user number. It can also be a string object, or any other class or structure. If we try to pass a value of another type for the ID parameter, we will get a compilation error, and when receiving the value from the ID, we will no longer need the operation of casting types and unpacking will not be applied either. In this way, we will avoid problems with type safety. Thus, by using a generic version of the class, we reduce the execution time and the number of potential errors. Generic methods. In addition to generic classes, you can also create generic methods that will also use universal parameters. Look at this example. A generic swap method is defined here, which accepts parameters by reference and changes their values. At the same time, in this case, it is not important what type these parameters represent. When calling the swap method, we type it with a certain type and pass values corresponding to this type. Okay, we are going further. The last topic for this lesson is null. Null and reference types. In addition to the standard values of the type of numbers, strings, the C# language has a special value, null, which actually indicates the absence of such a value, the absence of data. Until now, null appears as the default value for reference types. Before C# version 8, all reference types could safely be nulled. Like in this example. But starting with C# version 8, the concept of nullable types, nullable reference types, and nullable aware context, a nullable context in which nullable type references can be used, was introduced into the language. To define a type reference variable/parameter as a nullable variable/parameter, the type name is followed by a question mark. Like this. For example, the built-in method console.readLine, which reads a string from the console, returns exactly the value string with question mark, not just string. Why is this null value needed? In various situations, it is convenient for objects to be null, i.e. undefined. A standard example is working with a database that can contain null values, and we may not know in advance what we will get from the database, some certain value or null. At the same time, similar types of links that allow the assignment of the null value are available only in the nullable context. The nullable context is characterized by the following features. A type reference variable should be initialized to a specific value, not null. A nullable reference variable can be set to null, but must be checked for null before use. Unlike reference types, variables or parameters of meaningful types cannot be directly set to null. However, it is often convenient for a variable or parameter of a meaningful type to be nullable. For example, we want to retrieve a numeric value from a database that is potentially missing. That is, if the value is in the database, we will get a number; if not, then null. In order to assign null to a variable or parameter of significant type, the variable or parameter of significant type must represent a nullable type. And that's why a question mark is indicated after the name of the type. The nullable type has two properties. Value, a value of the object, has value, returns true if the object holds a certain value, and false if the object is null. This is all for this lesson. Thanks for watching, hope you enjoyed it. Don't forget to subscribe to the channel and hit the bell not to miss the following videos in the series. Feel free to leave a comment and like this video. And also I encourage you to help brave people in Ukraine to defend themselves in this horrible war. Please use the QR code or links in the description to visit charitable foundations that help Ukraine. Thanks. See you in the next videos.